Hello everybody, it's Mike here at Game from Scratch, and welcome back to the ongoing Godot tutorial series as we move into the third dimension. Today what we're going to look at is materials and shaders. Now I'm not actually going to teach you how to do shader programming. That on its own would take dozens upon dozens of videos. Instead what we're going to look at is how materials and shaders work in the Godot game engine. Another thing we're going to cover in a later video is the Godot visual shader programming interface. That'll probably be the next video you see. So here we're going to look at the code approach to creating shaders. But first, we're going to start things off with some materials. So here we are in Godot. I've just created an empty project here. And what I'm going to do is go ahead and make it a 3D scene. So we're going to be looking a little bit at 3D and a little bit at 2D in this particular example. So what I'm going to do is create something to put a material on. So let's go ahead, just create a mesh instance like so. And if you don't know what I'm doing here, be sure to watch the last tutorial, the introduction to 3D. It covers all of these topics. But what I'm going to do is go ahead and create a sphere like so, and then we will go ahead and edit said sphere. So now that we are actually in the sphere, here is the details of it. Actually, I'm happy with it as it stands. What we're actually interested in next is applying a material to the sphere. You click down the material category right here, and you will see if you drop it down, you have a choice between a shader material and a spatial material. Now, spatial material can be thought of as kind of a pre-configured shader material for you. It's got all the settings you need for a very common workflow for PBR or physically based rendering textures and colors and so on. And we're going to start there, and then we'll look at a shader material later on. So spatial material, if you've got a straightforward thing, you don't need to do anything custom with your material, you probably want to go with a spatial material. Now, the neat thing here is, now that we've gone ahead and created our material, if you notice how I drop this back down again, there's a menu option here for converting to shader material. So at any particular time, you can actually take your spatial material and turn it into a shader material anyways. So it's a good place to start either way. But now that we're here, let's go in and edit it, and we're going to look at some of the top level options for this spatial material. Now, this, as I mentioned just a second ago, is a PBR-based workflow. That means you have certain maps that are available here. You've got the albedo, metallic, roughness, normal, clear coat, rim coat, ambient occlusion, and so on. All of those maps go together, and you can provide textures or colors for each one of them, and they will interact with your underlying shape. So the end result, these interact with the lights in your scene, picked up by the camera, and represent the surface or the material of your object. So when you start putting textures on something, think about it like virtualized wallpapering. You're basically just slathering a texture on top of things. Now we can start things really, really simple. We can come in here to albedo, which is normally what if you're coming from a traditional background, you could think of this as the diffuse channel or the color channel. This is where the primary color for your texture comes from. So we could just come in here and define a color for it. So here you see we've got a greenish material. We can come down here, pick it, make it blue, and so on. If you want to do just a very straightforward, simple material, you can do it that way. You'll notice also up here we have options, a number of different flags. We can have it shaded or unshaded. This means it won't interact with the lights in the scene. We can have it so that it's transparent or not transparent. So that means if you're using texture maps that have a transparent channel, if it's a see-through color there, it will be see-through when rendered if you set that on. A lot of these things you will actually generally not come in unless you don't want to receive shadows or you don't want to have the ambient light affecting it. That's the light that's just kind of available in the world. It's part of the environment. By default, there will be an ambient light in your scene. You've also got settings so you can use the vertex colors. They're the color information encoded in the vertex or material information as the primary color of your thing. And you've also got a number of parameters. We're going to come back to the parameters in a second, specifically this diffuse mode. Diffuse, you can think of the way that light diffuses on a surface. It's the way that light interacts with a surface. And this is very important, but we will get back to it in just a second. Specular would be specular blob. Specular would be the way that shadows interact, I believe. My terminology there might be poor, so let's continue on anyways. What you're probably most interested in is first off albedo. And what you'll notice here is I've copied a number of different texture maps in here. They're already pre-configured. We won't necessarily use all of them, but I'm going to show you the process of applying textures to a 3D object. And one of the questions you may immediately have is, okay, where do I get these textures from? Cool thing is I got you covered. Over on DevGame, I've done a free resources guide, and part of it is the 3D models and resources section. You head on down here below the 3D models section, you will also find the texture map section. And I've got a number of different sources where you can get a ton of free textures out there. And the one I got in particular, it was from CC0 Textures. You can see it's right here. It's a series of JPEGs in 2, 4, or 8K. You download them, you extract them out, and the files you get, again, are these ones. And you see there's a naming convention that matches. So the first one is color. So you're going to do some of this. When you download texture maps, you're going to have to do a little bit of translation because the terminology for PBR workflows isn't always identical. So first thing we're going to do is we'll take the color map and we'll apply it to the albedo channel. So just drop it right there, and there you go. Now, the first time you use a texture, it might have a bit of a loading or an importing process, but we just brought it in. Now, make sure I don't have any weird flags on, because it's not actually showing up how I would have immediately expected it to do so. But there is, or did I put the wrong channel in there? So let me just go back into, oops. Okay, albedo is in there. Okay, that was really stupid of me. That was my bad. So this color channel that we did earlier, that also will tint the scene. So if you want it to look with just your textures, you're going to want to leave it to a white color. Otherwise, that will overall tint the channel. But there you can see we have now our color is defined. We got our planks and so on going forward. So now what we want to do, so albedo is defined and the tint is turned off. Next up, we could do the metallic map. So come down here, the met one here. And you'll notice if you look at this texture, it's basically just a bunch of white dots on a background. Well, those actually represent the nails in our texture. So that is going to determine how light interacts or how metal a surface is to the renderer. And you've actually got control over how much this texture influences. You can see the nails popping out as I increase the metallicness of the map. So that's how a metal map works. So we got albedo, metal. We can come in, we got a roughness map. So over here, roughness, drop that in, and boom, and that's scuffing on our surfaces. Another very similar thing, and this one's been around forever, is a normal map. So I'm going to drop that in, and then we can drop a normal map in just like so. And a normal map allows you to encode more information in there, like so, as if there were grooves or whatever in our boards. Even though your geometry doesn't actually show that, a normal map will encode that kind of information. So instead of having to model all this fine detail in there, you actually do like a high-res version and you render out the normal map. So that gives you, when the light interacts with the surface, it knows that there should be, say, a groove in this plank, and that information is encoded in the normal map. So it can make a simpler or low polygon object look like it's got a lot more detail than it really does. And we've got ambient occlusion map. So next one up here. This one is used to define how light or the ambient light in the scene interacts with the object. So you'll see here there's this groove line here. That's going to be one of these major points. So basically where ambient lighting should hit this thing, where it should cast shadows or where it shouldn't. That would be your ambient occlusion map, sorry there. And then finally we have a displacement map, I think is the only one I haven't done yet. And I think that would be the equivalent of a depth map. I generally find I almost never use a displacement map, so I'm just going to drop it in this particular case. But it's a way of displacing geometry on a surface. So there you can see our model is a bunch more detailed now than it was before. And what I could do is I could come back to any one of these settings for the most part, and we have sliders for how strong. So you can see the amount of shadowing that's happening in those lights. In the crevices, sorry, so as the light interacts with it, that's what the effect of the ambient occlusion map is. And then we come back here, we'll go to the normal map, for example, we can change the strength of it, and it makes a really profound effect on the surface. So those grooves become so much more pronounced. And that's basically what the various different texture maps in here are. Now, the final thing to talk about with the spatial material before we move on is the diffuse model, as I was talking about earlier on. So the diffuse model, there are a number of different options here. Burley, Lambert, they're all just mathematical equations for how light interacts with the surface, or the lighting model of the scene, or a Nair. So you're seeing not a huge amount of difference, but the one you're going to see a big difference on is Toon. And that is going to give you a more flat. So if you're going for that cell shaded look and you're using primary colors and high contrast, you're probably going to want to use Toon rendering. Otherwise, it's kind of up to you which you like. And then we got, again, the shading model here from the specular mode. And these are, Blinn and Pong have been around forever. And again, you can switch through them. You don't see a huge amount of difference. I don't have a lot of lights in this scene, though, so we're not going to see a lot of results, or pretty much any results, until we actually bring a proper light into the scene for it to interact with. But those are the two settings here that are going to be most interesting to you. Blend mode, you're almost always going to stay with mix, because if you go to like an additive model, you get weird results. If you go to a multiplied or subtracted model, almost unless you're doing some kind of a special effect, you're basically going to want to mix your things together as opposed to add them together. You can also switch between front and back face culling. So you see, I'm kind of showing you, I'm literally inside of the model. So it's determining the culling direction. So if you want to make, you would generally use color mode for something like this for a skybox, a model that was literally inside out. But for the most part, you're going to want to keep that to back culling. So that means that when you get inside of it, there's nothing there. And that's it. That is the basics of creating a spatial material. Again, there's other details here, but we're going to mostly get into them when you're in a very specific use case. So what we covered today is what you would use for 99.9% of game development. So we're not going to really touch on those edge case details. Now, once again, if you do want to get some texture maps to play around with, I will link all of those various different sources there. A lot of these have PBR-based texture, so you get like the multiple map formats, but you might have to do a little bit of translation in order to get things looking the way you want them to. So that was a shader, spatial material covered. Now we're going to go into it a little bit more is the shader. So I'm going to create here a new scene like so. And shaders are a bit of a different story. Basically, a shader is like a miniature program that runs in your GPU. They run millions and millions and millions of times, and you actually run, depending on the type of shader, there's different kinds of shaders out there we'll cover in a second. But for example, a fragment shader or a pixel shader runs once for each potential pixel that is drawn on screen. So it's responsible for determining the final color of the pixel that is going to be displayed to the end user. On top of that, there's Vertex shaders, Vertex shaders, which determine where an individual vertices is positioned. Again, they run through all of the vertexes, and the program is run every time for every program that was out there. And then we have a light shader. There's other shaders in the hardware map. There's like displacement and other geometry shaders. We actually don't support those in Godot, and we're not going to be covering them in this particular case. So what we want to do is go ahead and actually create a shader. So simple enough. We're working in 2D here, so let's give something to apply a shader to. So let's go 2D scene, and we will create a sprite in our scene like this. And now that we have a sprite, happily created sprite for us, see it's a sprite. It's got our guy going on right here. Now we need to go ahead and locate the material section of our sprite. It's just like working in 3D. They use different setups, but you can come here, you can create a new one, we'll drop this down. Instead of creating a canvas item material, which was the equivalent of a spatial material in 3D, we're going to create a new shader material, like so. You see it comes in, same end result. What we want to do is actually go ahead and edit this guy. So the shader here is undefined. We click that down, and we've got two options. We can either create a shader or a visual shader. The same end result, but a visual shader uses a built-in shader designer programming kind of system, and I will cover that in a different video. So what we want to cover here is the shader. So we're going to create a new shader like so, and then we will go ahead and edit said shader. So you'll notice the minute it hit, we got a new text editor down here that popped up in the tab for shaders, like so. And now we can go ahead and basically start writing code. Now this code is using Godot's custom shader language. For each major programming system out there, Metal, DirectX 3 or Direct3D, or GLSL, or OpenGL, they have their own shader language. For example, Direct3D uses HLSL, or I think high-level shader language, whereas OpenGL uses GLSL. And those two are very similar in the end, but what Godot has done is built their own simple language on top. It's very similar to GLSL, so if you're already familiar with it, it's kind of like GLSL with some familiarity layers built over top. Now, if you're interested in learning more about it, there's actually the fully documented shader language program. It's a pretty simple language for the most part if you already know shader programming. And coincidentally, if you don't know shader programming, I'll have some links for you down below as well. But I've done an OpenGL shader programming resource roundup a couple years ago. I'll make sure that this is available. And on top of that, there is an excellent resource called the Book of Shaders. I will link all of these things. So if you want to learn a bit more, these will get you started. And then hop into the Godot books to kind of just figure out the Godot specifics of it. And then another option, and I didn't load this one up to start because this just causes my CPU fans to go mad, but if you don't already know about Shader Toy, it's an excellent website with tons and tons and tons of shaders already implemented on it that you can adapt for working in your own preferred environment. So I will link all of these options down below. So if you want to get into and learn a little bit more about the shader side of things, they are available there. But what I'm going to do now is show you a very, very very simple shader in Godot language. So first off, we're going to start with see how we got this error message at the bottom, expected shader type at the beginning of shader. So first thing we need to do is tell it what kind of shader we are dealing with. And there are a couple of options here. Canvas item is what you use if you are dealing with 2D. 3D, it's, let me get my naming convention down. 3D, it's called spatial, and then the another option is particle. So those are the various different options that are out there. And this one is something called a fragment shader. Now, what that kind of, if you've ever done any C or C++ programming, you know there's an entry point called main. Well, in the case of a fragment shader, the entrance point in Godot is called fragment. And this is a function that is going to be called for every pixel on display, or every potential pixel that is displayed or potentially displayed. So this is going to be called over and over and over again. So as it goes, as the renderer goes through, it'll go through all of the different points in this guy and call this function. So what we're going to do now is get the color. So as this is called each particular time, we want to get the color at the current location. So vec4 color equals, you'll notice it's a very C-like language. And then there's a function here built in called texture. And we've also got a couple of parameters that are built in. So this is the bound texture to this guy. So that's going to get me a reference to this Godot icon PNG image. And then the UV is the current U and V coordinate that we're at this particular pass through the fragment. So these can be thought of as like global variables that are passed into your shader automatically. Once again, all of this stuff is actually documented in the shader language detail. So you got all the different variable types you're dealing with, as well as all of the defined functions should be in here as well. So there's all of the functions that are available to you. And then here are all the predefined. So if you're dealing with a vertex shader, here are all the built-in variables for a vertex shader. And then here are all the ones for a fragment shader. So you can see here the UV that we were using here, and so on. And then the texture should be here somewhere as well. So since we're dealing with, this is the documentation for 3D. In 2D, it's texture. So that's where we get these particular values from. And then I'm going to use semicolon line terminator, again, another C thing. And then what we're going to do is for each vertex or each fragment in our shader, each time we run through it, all we're going to do is add 50% of redness to this. This is going to tint our overall image when this is actually run. And then our output is defined as a color here. So we're saying our color equals color. Now you'll notice obviously that shader program is case sensitive. And you'll also notice that I missed a semicolon on the first line. So we get real-time compilation of our shader. And then you'll notice as soon as it works, boom, it's applied in real time in the viewport. So there is the effect of our shader. So if we wanted to tint it lightly, we could go ahead and turn this into a 1. And you will see it shaded much lighter. Or here we could say 9, and then boom, it's going to be a lot brighter. Or we could say apply it to the green channel or the blue channel. Continue on. So there is the ultimate shader here. This is just going to apply a simple red tint to every item in the scene. So you see again, this is a piece of code that is called for every single pixel on the screen or in this image, and all we do is get the current color at that location, set it to 50% more red, and then set the variable out of color. Now once again, if you come back here to the documentation and you'll scroll down, so here's the canvas item that we're dealing with, you'll see all of the various different built-ins are here. So you'll see there's both ins, so these are parameters that are passed into you, such as location, time, and so on, and then the out value, and these are the things that your shader can actually change. So we can change the UV, the vertex, the color, and the point size. Okay, so hopefully that made at least a basic amount of sense. Now let's look at a vertex shader. And the cool thing with Godot is generally these are actually separate things, but here it actually kind of builds them into the same spot. So what we can do, just like we did with the fragment, so void fragment, we can also do void vertex. Now, as this is determined for each color, this is determined for each vertices in our object. So I'm going to go ahead and we're just going to come up here and we're going to say vertex, again, remember that was one of the values we can change. X equals vertex X times time times speed. Now, that doesn't help us much because we don't have speed defined. So let's go ahead up here and we'll say uniform float speed equals 1.0. All right, so that is defined. And that ran pretty fast. So let's change this down to 1.001. And there you'll see over time, our shader, okay, that might be a little bit on the slow side. And it will expand. So actually we'll do this, we'll save the scene. Yeah, no 2D, we'll run it. All right, so let's put the speed back to 1.0 and actually not run it here, but we'll run it in the actual editor. So let's select our scene, node 2D, go ahead and run that, and there you will see the effect of our vertex shaders. It's expanding on the X at a rate of 1.0, and that's kind of cool, actually. Now, you'll notice I also put this value in here. So go back to the shader. There's this uniform here. Well, what does that actually mean? Well, if we come back here and we select this guy, okay, let me go back up. So go back up here. You will notice under the shader material selected, if I drop down shader params, we now actually have a speed value. So we can change that out however we wish. So let's say 3, like so. And then we run it, we're going to see we're going to expand really, really fast. Or exceedingly fast, so we can make that 15, for example. And then boom. And off we go. So basically what uniform, when you tag a script as, let me just, there we go. When you tag a script variable as uniform, it's basically saying this is an input parameter. And then you can actually configure that value in the inspector as you wish here. Or if you don't do anything here, get rid of that, or let's just delete it completely, then the default value that you specified in your code was available. So what's really cool about uniforms is it allows you to basically, you can create your shaders and then hand it off to a designer, and they can tweak individual settings as is most appropriate to them. But they don't have to get into the nitty gritty of it. So for example, if we wanted to, we could have made the color or the tint value, we could have made that a uniform, and then it would have shown up here. So if I said, for example, uniform vec for color 2, like so, you'll notice, then boom, they're immediately available up here. Now, one of the things you notice here is, so vector is used quite commonly. This is basically just 4 value types kind of in one data structure. And that's where you get your red, your green, your blue, and your alpha in there. But the problem here is that doesn't make a whole lot of sense because you're not dealing with X, Y, Z coordinates here. Now, the cool thing is there's also an ability here. So if you wanted to go ahead and give Godot a little bit more information on how this particular uniform vec4 is, you can actually go ahead and say, this is a hint color. So you just put a colon and say hint color, and this means it now knows that it is a color. On top of that, even cooler, is it puts up the appropriate editor. Again, in the documentation, it will tell you what all the various different hint options are. So hint color, number range, hint, so on. So you have various different options that are built in, and then you can use those particular values in your code to provide, this nicer feedback. So if people are working with, they don't have to just enter raw numbers. It knows it's a color that's going into that vector 4, and it puts up the appropriate thing. Where it's the same way as if I had made this a uniform float, meaning of life equals 42, hint range, like so, we will see I screwed something up. Expression found, unexpected expression, It's a hint on the wrong side. Give me 1 second here. Oops, my bad. I have to give the range that you're actually hinting for. So you go, we got our meaning of life, and I can come in here and go hint, range, and then we can give the lower and the upper, and then if we want the intervals, so I could say 1.0, 50.0, and we'll go up by 1.0 per. So that's why I didn't give you the actual range values that it needs to work. And then we'll give it the default value that makes sense. We'll run that off, and you'll notice over here, you got your default value of 42, but we can move this now in intervals of 1, and it will go from 1 to 50. So again, using uniforms and then hints, you can specify how the editor is going to handle this particular data type, which is actually really cool. Again, if you are developing your shaders for working with somebody else, a lot of convenience here by providing these different hints. And again, there are a couple of different hints. So you've got hint color, hint range, hint albedo, hint black albedo, hint normal, hint white, hint black, and hint ancio. For the various different options. Again, the documentation has full details on all of those particular things. And that's kind of it, to be honest. So that's what we're going to cover here today. So first we started off by showing you how to create a 3D spatial material. The same process basically as 2D for the most part, but you've got more things there because 2D is not a PBR workflow. But simply put, you've got a number of different textures that work together with the lighting model to render your particular scene. And another thing to keep in mind is you are not committed forever. So once you've got this guy to the way you want it to be, if you want, you could come back into your particular material and convert it to a shader material at any particular time, and it will do that for you. Over here, we did a shader material. We actually showcased two of the different shader material options. We've got the fragment material and the vertex material, or vertex shader being shown here. And again, these are just functions that are called over and over and over again as your frame is rendered, once for each potential pixel and one for each vertex in the object. And they kind of do like little small calculations on each, and it's amazing the power that you've got with shaders, but you got to kind of switch your brain into shader mode. You also can set up variables that persist. You can also configure variables like uniforms, which are parameters that can be passed into your shader. And as you saw, you can use hints so that the editor knows what kind of data is going to go into that, so it can display the appropriate properties or editor over here. And that's where we're going to leave it. Now, again, one thing I'm going to cover at a later date is the visual shader. So if we wanted to create our material here, we could have instead created a shader material, and then that shader material, when we created it, we could have created it using, I'm in a spatial material here, but when we had the option for creating it using a visual shader editor, we will look at that in its own video. That's basically just kind of a way of writing this kind of code, the kind of stuff that we were dealt with this guy right here. Just instead of this way, you can do it using a visual flowchart kind of approach to things. So we'll cover that at a later date. So that is materials and shaders, at least the very basics of it in the Godot game engine. Hopefully that was useful to you. It's a very in-depth subject, of course. And again, if you want to learn more about shaders in general, I can not recommend Book of Shaders anymore. It is a great resource for here. It's not complete by any means, but these couples will get you up. You'll understand the basics of what a shader is. You'll learn what uniforms are. You'll dealing with things like colors, shapes, matrices, patterns, random noise, and so on. And hopefully it all gets finished eventually, and then there's a number of examples from it. So I do highly recommend you check this out. It's a really good introductory source. And then on top of that, the documentation for Godot itself shows you what their own custom shader language is all about. And there's tons of resources out there. And then I've got this link to various different shader tools. It's a few years out of date, but most of the materials here will still be relevant today. And if you've found yourself a book on GLSL or HLSL shaders, you should probably be pretty good to adapt that stuff over into the world of Godot. The Godot shading language and the GLSL shading language are very similar. The HLSL shader language is also quite similar in approach, so you shouldn't have any real big difficulties adapting any learning materials over when you're working with Godot. So anyways, hope you found that useful, and I will talk to you all later. Goodbye for now.